Hey everyone, my name is Dr. Chin, and I'm making a quick video to describe how we could test a simple two-way moderation analysis within an SEM framework. And so for this example, I kind of cobbled together some variables here that we can play with to demonstrate. It's not the best example theoretically to talk about how these constructs may be related, but just simply because of time constraints, this is the best that I can come up with right now, given the amount of time that I have left. So as you can see over here, we're going to test a simple moderation model with conscientiousness. Conscientiousness is one of the big 5 personality traits. And so higher levels of conscientiousness, meaning, you're typically more detailed, more organized, more systematic, those kinds of things. This construct Ptsd refers to the level of trauma and stress-related symptoms that students were reporting due to COVID. And so we have that as the outcome of interest. And acceptance. Acceptance is one of the coping skills identified in the COPE scale, and basically talks about the extent to which one decides that they're just gonna live with it and basically try to accept that things are not gonna change. And so that's an interesting construct too, because, obviously depending on the stressor, for some stressors, you kind of have to practice acceptance, especially if it's something that you can't change. And then for other things where you're not able to change, maybe other types of coping mechanisms. So for this particular moderation model within the context of SEM, these are the 3 constructs. You'll see that we're going to model a covariance between conscientiousness and acceptance as well within the particular model, just because it seems to make sense to me in my mind that these 2 latent constructs would be correlated. And we see here the indicators for each one. For a conscientiousness, I just pick 3. Actually, I think for this one, these are 3 item parcels that I created randomly, so that it would match with the 3 items for acceptance. Again, I will say, actually, I think acceptance has 4 indicators in here. Just for convenience and for demonstration's sake, I'm using the first 3 indicators here. I will talk about why this will be helpful when it comes to modeling the moderation in regards to creating the interaction construct. And then for Ptsd, we used PCL, and that was parceled into 4 main domains representing the 4 symptom clusters of Ptsd. So that's just to give you an overview on the type of analysis that we're going to run in this demonstration. So first of all, we are going to set a working drive, and this will be specific for each computer on each local machine. Make sure you locate where your data set is in your computer. And typically you don't need to set your working directory, but sometimes I do, just to make sure. And then use the read.csv function so that you can call the data set. The name of this data set is no out, because I actually cleaned up the data set a little bit earlier by removing multivariate outliers and dealing with missing data. So that's the reason why it's called no out for this particular example. And we're going to import the data set into a global environment. See here that it has 153 observations and 26 variables. If you were to use the mastery function, we can see here the descriptive statistics for each of the variables. You can see that we have 1, 2, 3, 4, 5, 6, 7, 8 COPE indicators. We're not going to use all of them. I think we're just going to use, I believe, maybe the first 3. And then for PCL, we're going to use, these are item parcels from the 4 main domains for the PCL5 scale. And we actually have I made parcels for each subscale in the Big 5 inventory as well. BFI O1, O2, and O3 represent item parcels for openness to experience. BFI E1 and 2, these represent item parcels for extraversion. BFI A1 and 2 and 3, this represents, what is this one? Trying to recall what BFI means. So let me look up the measures themselves. Sorry about that, just bear with me. And what I'll do is I'll post the files that I'm using for this demonstration in OSF as well, so you can try to recreate this on your own. Where is the measure? This one. So no, it's not this one. Okay. Anyways, we're actually not going to be dealing with that particular subscale for the BFI. We're actually going to be using the conscientious subscale, which is BFI C2, C3, and C1. And then we've got the neuroticism scale as well. So again, we're going to use BFI C2, 3, and 1 in order for them to be the indicators for conscientiousness. So we can also use the view function, and this enables us to see the actual items. And you can see here the item parcels are basically averages for the items that make up each parcel. That's why we've got decimals over here for PCL, and same thing as well for the others. And again, the interest here is BFI C 1, 2, 1, 2, 1, 2, and 3. Sometimes I like to use the names function to get a sense of the variables here. This will especially be helpful when it comes to trying to locate specifically which columns the variables are for our indicators when we attempt to create the interaction indicators to later use in the SEM model. So there are two libraries that you want to load: SEMtools as well as SEMplot. SEMtools is you're going to use that package in order for you to run the SEM, and for SEMplot, I'm going to use that to visualize the parameters that we are estimating. I like to use SEMplot because even though I'm not super skilled in making full use of all the features in SEMplot, I do like to look at it because sometimes it gives me a visual of just in case if there are any parameters that I may be missing. And you could also look at the output if you want to make sure that you are estimating the parameters that you are wanting to estimate. Okay, so once you load these two libraries, the first function that we're going to use is indprod. And by the way, it's important that you pay attention to the uppercase and lowercase letters as well. So this is going to help us make the product terms for us to put together to create the interaction construct. So master is the name of the data set, just like how we just named over here. And VAR1, that is basically identifying the first variable that you want for it to be part of the interaction. And this is actually going to be columns 2 through 4. So 1, 2, 3, 4. So that's code 13, 21, and 44. And then the variable 2 is the other variable. And that is actually going to be 22 through 24. If you do count this one by one, 22 through 24 is basically BFI C2, 3, and 1. Match equals true. Now, what is that? Well, when you create the interaction indicators, basically what you're doing is you are taking or at least this is how some people might do it. They would take every combination of your indicators here, variables 1 and variables 2, and multiply them, and do that for every pairwise generalized combination. We're not going to do that. In fact, what Marsh et al. Suggested is actually with matched pairs, you can actually get pretty decent parameters as well without overloading the measurement model itself, so that we don't over-identify with the measurement model as opposed to the structural models. So I like match. Basically what it does, and this is the reason why when you item parcel, you want to make sure that your items that you have the same number of item parcels for your two measures that for two constructs that you want to conduct the interaction term with. So in this case, it's 3 over here. So what it's going to do is it's going to take COPE13 multiplied by BFIC1, COPE21 multiplied by BFIC2, and COPE44 multiplied by BFIC3. And we'll see that in just a little bit. The residual C is a way of creating the interaction indicators that are not at all correlated with their first order or their original variables. This is to take care of issues of multicollinearity, so we can get more stable parameter estimates. This is actually described further in Todd Little's paper here in 2006. And just to give you an intuitive sense of what's going on, for every product term, so let's say, for example, if we were to multiply COPE13 and BFIC1, you multiply that, we are going to regress that on the first order effect indicators of all of the constructs. So BFIC1 multiplied by COPE13 is going to be regressed on COPE13, COPE21, COPE44, BFIC 1, 2, and 3. And from that regression, we are going to save the residual from that regression, because that is the leftover variability that is not captured by your relationship. I'm going to use that as the indicator for your interaction construct, and that completely orthogonal makes sure that your interaction term that you've created, let's say BFIC1 multiplied by COPE13, that indicator representing one type of interaction, that is orthogonal to your first order indicators here. So we can take care of multicollinearity in that sense. So that's just a quick explanation of why we put residual C equals true. There are other ways for you to create the interaction terms as well. You can also use the mean centering approach and other approaches, but I like the residual, using the residual approach. So I'm gonna run that. And basically what we're doing is, in this data set, we are going to do a match pairs way of creating the interaction terms using the residual approach. I'm gonna import this in, make this another data frame called master1. And this is the new data set, master1, and I'm calling them names. And as you can see, we have COPE13 multiplied by BFIC2, COPE21 multiplied by BFIC3, COPE44 multiplied by BFIC1. That's the match pairs interaction terms. And these interaction terms are from the residuals when you take the leftover residual after doing the regression. Okay, so next is we're gonna build the measurement model. Then, that includes the interaction term. We're going to build the structural model, and we're also going to be a little bit specific in regards to what covariances we want to allow here. Okay, so let's walk through this really quick. So the measurement model, this should be pretty standard, especially the first 3 lines over here, basically saying PCL equals tilde. So PCL is defined by the item parcels PCL 1, 2, 3, and 4. Except as a construct is defined by, that's equals tilde, by these indicators here, COPE13, 21, and 44. And then conscientious, this is defined by the item parcels BIC 1, 2, and 3. And we also need to make a latent interaction term. So we're going to call this interaction equals tilde, and this is going to be defined by the indicator interaction terms that we just created here. So Once we create the measurement model, then we'll make the structural model. Structural model is PCL, the latent construct PCL, is regressed upon, acceptance plus conscientiousness. So this represents the two main effects, and the interaction term as a latent construct as well. We're also going to allow the acceptance and conscientiousness to co-vary with each other, because it makes sense in my mind, at least theoretically, for these two constructs to be correlated. And then we'll just constrain all of the other covariances between the other latent constructs to be 0. And I have a note over here too. By default, R is going to fix the mean of the latent variables to 0 in order to identify the mean structural aspect of the model, such as the intercepts of the indicators. I've actually tried to do this differently when it comes to trying to estimate the latent variables. And all you got to do is basically just fix the, each indicator so just pick one indicator for each latent variable, fix them to 0, and you transfer its mean over to the latent variable, and you let R know to estimate the latent variables freely as well. The problem is that I ran into some issues when it came to probing the interaction, so we're just going to stick with this for now. It's not the best way to visualize things when it comes to probing, but it still works in terms of trying to explain. As long as you explain to people what the scales mean when you start probing the interaction and try to visualize it. So that's basically the syntax over here for creating the measurement and structural model. And specifying the one covariance, and then we're not really doing anything in regards to latent variables. Just by default, R is going to fix the mean of the latent variables to 0 so that we can identify the mean structure. Then we're going to fit the model. So SEM is the function. Moderation 1 is the model that we just created over here. Data is master 1. So that's the data set that includes the interaction terms. We're going to use maximum likelihood as the estimator. This is kind of redundant, but I'm basically saying that all variances should be, all latent variables should have a covariance of 0 unless otherwise indicated, just to make sure. And then mean structure equals true, because we are going to estimate the mean structure. We need that in order to visualize the interaction, if there is an interaction. All right, so this is where the SEM plots come into play. We're going to use the function SEM pass with P capitalized. Fit 1 is the model that we just fitted, and we want the parameters to be standardized parameter estimates in the picture. Layout is tree. There's a bunch of different layouts, tree 2, circle 2, so on and so forth. It just happens to work really well for this one, enough so that we can actually see what the arrows are. So what we want, because PCL is the outcome interest over here, we want unidirectional arrows from your latent predictors to your outcome of interest. So PCL, and we have one arrow over here. One arrow over here from acceptance to PCL, another unidirectional arrow from conscientiousness to PCL, and then the interaction term that you just created. This should be a unidirectional arrow as well. You can see over here that there's actually a covariance between acceptance and conscientiousness, just like what we specified, but the other covariances is actually 0. So this looks good. This is exactly the types of parameters that we are wanting to estimate over here. So let's get the results. So just put in the model that you just fitted. Ask for standardized parameter estimates as well when you can calculate them, and then ask for R square as well when you can calculate them. And first of all, what I usually do is I like to check for Haywood cases, just in case there are some issues with estimation for R square, for example. We want to make sure that none of these R squares is more than 1, because that would be a parameter estimate that would not make sense given that it is R square. And in terms of the standardized variances, these are the residual variances. Make sure that these are not negative. That will be standardized underscore all. So that would take care of mostly Hayward cases. Most Hayward cases will appear in the residual variances on your square. And you can see here that we have estimated the intercepts for our indicators, except for the latent variables. These were their means were fixed to 0 in order to identify them. We've allowed the covariance between acceptance and conscientiousness, so we get an estimate for that, but all others were constrained to 0, just like what we asked for. And this is the structural model right here. And so most people would typically look at this p-value over here. We can see that our interaction is actually not statistically significant, but we appear to have a simple main effect over here for acceptance predicting PCL, suggesting that as acceptance goes up, PDLC symptoms goes up as well. Again, not the best theoretical model here, because I think the interpretation gets a little bit murky given how the items are defined for acceptance. But just for the sake of, again, this demonstration, just wanted to show you how we would interpret the interaction as well as the simple main effects. And then here we got the factor loadings for each of the indicators on the respective latent constructs. Okay. We can also get the global fit indices. So just type in fit measures with M capitalized and locate the object that you just created, the model that you just created. CFI is actually 0.96. CLI is 0.95. That's actually pretty good. We want those to be more than 0.95 for excellent model fit. REMC is 0.053. And we want the lower confidence interval and the upper confidence interval to be less than 0.08. So that's actually pretty good. And SRMR, we want that to be less than 0.08 or less than 0.06. Either way, it's actually pretty good. So in this sense, actually, the global fit indices are a little bit misleading in terms of how well we're able to reproduce the mean structure and variance covariance matrix. So it's important that we look not just at the global fit indices, but also at the specific parameter estimates. Okay, assuming, this is assuming, because obviously in this case, our interaction was not significant. Assuming that, and I suspect it's because we probably should have a little bit more observations here so that we get more stable parameter estimates. But assuming that you have a significant interaction, can you actually probe this interaction and also visualize this? Now, to do that, you would use probe 2ARC. This is for working with interaction terms that are residual centered, just like what we asked for in the beginning, way back over here. If you use mean center, then you would use, you would type in probe 2AMC. Fit one is a model that we just fit the measurement and structural models. And in terms of the predictive variables, we've got acceptance, conscientiousness, interaction. This is the outcome. We're going to say in this sense conceptually that the moderator variable is acceptance, given that acceptance is a coping skill, whereas conscientiousness is more like a personality trait. It would make sense for us to think more about modulating coping skill. And then we're going to probe this at the values of acceptance at -1, 0, and 1. Now remember, by default, Louvain is going to fix the mean of the latent variables at 0. So that's why we're asking for 0, because that's the center. So all the latent variables are centered at 0. And the units with -1 and 1 is basically one variance below the mean and one variance above the mean. So we're gonna basically try to probe this interaction at those moderator values, given how Louvain is identifying the mean of all of the latent variables. Then we can use plot probe with P capitalized, and we put in the interaction.probe, which is the object that we just created over here. We're gonna set the x-axis to -2, 2 to cover the range over here for conscientiousness. And then the y-axis is going to be PCL, and the x-axis is going to be conscientiousness. And you'll see different lines. Each line is going to represent each value of the acceptance moderator variable. And we're going to ask for the legend as well. So as you can see over here, visually, it does seem pretty tempting to say that there is an interaction that is going on. But again, the statistical significance does not tell us that. You might also notice that when conscientiousness equals to 0, PCL appears to be 0, and acceptance, as well as the intercept for acceptance, all appears to be focused over here. And the reason why for that is, again, because all of the latent variables were fixed to have a mean of 0. And so again, this will really only be helpful if you have a statistically significant interaction that you wanted to show in the paper that you're wanting to publish. So that's it in regards to conducting a simple simple moderation example within the framework of structural equation modeling. I hope that was helpful. I'll post all the materials for reproducing this example in USF, and let me know if you have questions.